Yeah, I'm so excited to be here. Good morning, everyone, and welcome to the AI Realize Summit. This is my second, so I'm very excited to be here. I'm Maher Hanafi, Senior VP of Engineering at BetterWorks. For those of us who have been on the ground leading businesses in technology, we all know that there's a little bit of a hype around building generative AI. And there's in particular, like a very big AI, what I call AI paradox, because it feels like the AI is so interesting, so exciting, so easy to achieve, especially when you do MVP and demos. But there is like consistently, like you as you try to build AI, you bump into obstacles. You really go against the sharp edges of reality. So the hype around AI is everywhere. It's visible intelligence, the user experiences you can get out of this. But when you are responsible of integrating these systems into existing systems, especially in enterprise, the truth, the AI model you pick is just it's the tip of the iceberg. It's there's a lot of work to be done. There are a lot of hidden complexity. So that's why my talk today is titled The AI Iceberg: What Lies Beneath Your Enterprise AI Application. I'm here to explore with you the complex, non-obvious, fundamental aspects of building AI in enterprise. And I'm going hopefully to give you at least my version of a playbook that I have been building over time, building leading AI initiatives. So let's get started. Quick intro. Again, I lead engineering at BetterWorks. I've been in different engineering leadership positions. I'm also very active in the AI community. I'm doing my best to keep up as a technology leader. Things move really fast, so it's very important to stay informed, contribute to communities, lead some board advisory meetings and sessions, and also contribute as an ambassador to some initiatives like the AI Accelerator Institute. Very active in AI Realized, and I'm so happy to have this tight connection with the community here. My next slide is about BetterWorks. Very quick introduction, but focus on the AI aspect here and talk about that kind of promise of AI that we are not talking about just one isolated feature. We're talking about so many things happening at the same time, especially in enterprise application like BetterWorks as an example, which is in the HR tech space. It's very important to understand that success depends on the basic principle of building embedded AI. It should be everywhere. It should interconnect all of these features. It should be interwoven within AI. So the core value proposition of implementing AI here is not to just have that kind of AI checkmark powered by AI, but more to build these connected experiences while exposing actionable insights and bringing them to the surface to the user where they are and the flow fork. The philosophy of at least where we adopted at BetterWorks is that we are building an AI-based, people-centered approach to our performance and talent management. And to truly realize this kind of power of generative AI, we must integrate it horizontally across all of these features. This means building a common intelligence layer that spans across all of these domains and all of these features that we have already at BetterWorks to provide more intelligence across the entire platform rather than just isolated pockets here and there. Achieving this dense horizontal integrated intelligence while maintaining the non-negotiables of cost, quality, performance, security, and all of that has been my daily challenge in my kind of explorations and experimentation led me to understand the complexity of the AI, what I ended up calling the AI iceberg. So what I will be covering today, obviously the problem, this AI paradox, which highlights the gap between the promise of AI and the reality and the complexity of AI. Crucially, we'll dissect the high stakes of building AI and how leaders and business leaders are just under an AI imperative to go and build AI. And at the end of the conversation, we'll talk about the solution, what I ended up calling the AI 3 O's: orchestration, observability, and optimization. This will help us understand how to do AI properly and how to prepare for the next wave of AI. We should not forget AI is moving so fast. The pace of innovation is crazy fast. And we need to really build AI that can sustain time. And in between the problem and the solution, I will be covering some strategic foundational frameworks that I use, things that I developed over time to really craft blueprints for success for engineering and business leaders, and also help you understand how you go from these blueprints, from these theories to impact and achieve success with a realistic look at your AI implementation. So for the first one, let's start with the problem, focus a little bit on it. We need to align ourselves on the gap between promise and the reality here. And I think one of the most important data points that we had recently is this MIT report that we all know now. It's very infamous. The 95% of Gen AI pilots are failing. And you might be asking why they're failing, or why this much failure percentage. I think, and I do believe, because leaders are in a position where they are imperatively asked to achieve asking tasks to build AI solutions that still need to be powerful, ethical, and secure. And that's not easy to achieve. And as we are learning over time, building AI over the last few years, success requires moving beyond the visible aspect of AI, which is the LLMs, the models, the hype around the new model coming every week, but more go into the deeper aspects of understanding the complex and risky foundational layers, what I ended up calling the AI iceberg. So executive success here is so depending on mastering these hidden complexity that you don't know about when you start planning for all of this, which include infrastructure, cost, performance, and security. And we'll go deeper into looking at that iceberg. This slide is definitely the most important diagram I have in this presentation. I think it really illustrates the metaphor I wanted to communicate through this presentation today, that the core problem here is that what lies beneath your AI application is so complex and hard and things that you need to adapt to and learn compared to what is on the tip of the iceberg. We all know the intelligence, the embedded AI, how exciting these AI experiences are. But when you are in an enterprise kind of environment, you have other challenges. You have a lot of things that are to just achieve the success of your implementation, it requires you moving below the visible layer. You really go underwater here and go and understand what is the true challenge and understand the risk coming with building these AI. To summarize the ideas I had put together here, I think I'm going to name a few. Obviously, you can see more here and highlight the ones that over time I experienced myself and felt like, oh, I was not expecting this. I think performance in general is one of these critical areas because it connects so immediately with the user satisfaction. If you cannot achieve performance, your AI is failing and it's behind compared to the competition. Even if it's outside of the framework of your main application, people will always name other products in AI and say, this has a better performance. So performance here, we're talking about throughput, latency, cold starts. We'll cover this more in the presentation, but like deeply technical performance. A second aspect of this is inference. It's the science of how you run these models and how you configure everything and make sure that you serve AI the best way possible. This is a science on itself and like a space that needs to be understood. And as a technology leader or business leader, you need to get yourself and your team upskilled in this area to get to achieve inference in the best way possible. Understanding the models, the data, evaluating, understanding bias, mitigation, all of these things, and accuracy of your responses is so important. This is not, you cannot just trust any model you use that's going to deliver the best accurate result or output. So you need to work on that and optimize for it as much as you can. Cost and operations is so important. You will be going through a buy versus build decision on a weekly basis. You have to control the spiral cost of AI and really try to demonstrate ROI, which connects us back with the MIT report. Achieving AI at no ROI is a failure, considered failure based on that. One of the other problems is debugging in infrastructure. Like it's so hard today, and to really, there's like a lot of complexity that comes with being able to reproduce AI bugs and issues and debug them and trace them end to end and be able to really put the finger on what is going wrong and fix it. So that is a different challenge compared to classical systems, I would say. There's another aspect I want to highlight here that we don't talk about a lot, which is the skills and talent gap. The pace of innovation AI is so rapid that it creates over time a talent gap. Like we like it or not, the more you work on building AI, the more AI is moving fast and the more that gap is growing. So you need to have a really clear strategy on your team and on yourself as a business leader or a technology leader to really make sure that gap doesn't grow to a significant kind of level. And then last but not least, security. Like building AI is fun and exciting, but sometimes doing that will expose you yourself to security concerns, privacy leakage, and access controls. We'll dig deeper into some of this later, but in the next slide, I really wanted to highlight some of the frameworks and some of the data points and the challenges I've been facing. This one here, if the AI iceberg showed us the complexity beneath the surface, I ended up with this kind of other metaphor of an AI trade-off pyramid. Why this is important? Because this is the constant strategic tension I face every day. When building AI in an enterprise, you need to understand that managing these different levels or levers, sorry, it's so important because they are interconnected but also inherently competitive. You have cost, you have quality, throughput, and latency. If you want to have a higher cost, as an example, you might need a larger model. That will increase your cost and latency. If you want to lower your latency, you might need to sacrifice your throughput or invest into better GPUs, which makes the hardware more expensive. If you want to lower the cost, you might need to use a smaller model or a smaller GPU that will impact your quality and latency. So this means that moving the needle on any of these parameters is invariably impacts it will impact the other ones. And the strategic decisions you make must acknowledge the fact that you cannot move all of these and optimize them all at the same time, but just you need to find that kind of sweet spot, which I call here the AI nexus, that will achieve satisfied criterias for the given enterprise use case. So it's never perfect for every all of these parameters, but it will be ideal or optimal for the use case you have at hand. This understanding this that challenge that honestly you will be facing more frequently than you think is and needed. And the key takeaway here that unless you actively manage this kind of trade-off, you will always end up with the default, which is very high, more expensive AI, low ROI, low quality, and even low latency. Another factor I want to highlight here, like knowing and understanding the AI iceberg, understanding all the trade-offs you need to do, you need also to understand that as we are trying to achieve that AI nexus, we need to recognize that the underlying environment itself is changing. There is a shift in the architecture of building AI from specialized verticals to unified horizontal intelligence. Historically, AI is all about getting really good at one thing, doing it the best way possible. But the nature of enterprise AI architecture is changing, that we are seeing a more movement towards broader unified layers, cross-domain horizontal features, and achieving AI at that level will make it even more complex by design. And understanding that as you are trying to move all of these levers we talked about earlier, the environment itself is shifting and changing, and you need to keep consistently going into a loop to go back and improve all of these at once. So this will bring me directly to the strategic planning that is required to manage new architecture in the changing environment. And I will try here at least to share what I have been thinking about from an executive AI playbook, what frameworks work really well for me and my teams, and how can we are trying to be on the 5% success rates based on the report. If you have been at AI Realize last year, you recognize definitely this framework here, the AI flywheel framework. So I'm going to skip talking about the planning and building phases. I will focus a little bit more today on the running and optimize, mainly on optimize, but part of it is running. So in the running phase, I talked about the deployment, performance, and observability. In building AI, observability is dealing with a new system, new parameters, new metrics that are definitely so important to the optimize phase. You need to be able to report on data to be able to optimize these same on these metrics. The optimize phase, which based on my experience, again, this is a flywheel. So you go through this and from one feature to another, from one kind of sprint to another. But I found out I have been spending way more time on optimizing than the other ones over time as we get better at building AI. In the optimizing phase this is where the orchestration that is needed to achieve and move towards more like complex AI, more agentic AI, workflow-based AI, and all of that, it requires you to orchestrate all of this system in the best way possible and optimize it for cost efficiency and performance efficiency. The cycles here ensures that every success achieved in optimizing feeds back into the next planning phase and set up the next wave of AI for success. Another framework I've been really able to develop over time is what I call the AI decision framework. This is a foundational tool for strategic clarity. It's not necessarily very technical, but it's very strategic. And it goes on these different layers, what I call the how, the what, and the reality. The how is the top layer that will address the most fundamental choices regarding deployment and control. This is where you just talk about proprietary AI versus open source, off the shelf, or self-hosted. I assume at this stage we really understand this problem better. But these are decisions you need to understand and a question you need to answer to get to know how you will be building AI. The next layer, the core efficiency, is this will answer the question of, is the AI fit for a specific purpose I have or the use case I have? Here you will be thinking about the task-specific performance, the model properties, the training data and integrity, managing bias, and how data was trained to achieve that feature. And the last step here on the bottom is what I call the operational readiness. This is the reality check. This is where the rubber meets the road, honestly. By really looking into these hidden complexity, this will do a reality check if your organization can actually support the solution in production. This is where you will talk about technical performance, scalability, total cost of ownership, security control, integration, all of that. This framework, in my opinion, is so important for making choices that avoid pitfalls waiting beneath the AI iceberg. Another way to look at this problem also, and a little bit focus here on the technical decisions. As AI evolve, we get a lot of options. So there's a spectrum of possibility on how to build AI. And if you think about this problem, you can go up in this framework and look for more convenience, or go down and take more control. I think the top part of the options you have, as service, as a software as a service, or AI as a service, these systems will provide you more convenience. Things like, again, Amazon Q, things like a very specific trained AI that you can get through a service will get you deliver the features you intend to, but you will have very easy way to integrate this, but way less control than the other options. In the middle options, you'll see model as a service. This is where you have your cloud providers giving you like access to Amazon Bedrock and all the models behind it, or very specific AI providers like OpenAI, ChatGPT, or GPT API, and all of that. Or you have the platform as a service. This is where you get access to managed services like Amazon SageMaker to just build your AI. And then on the bottom, you have infrastructure as a service. This is where the deepest layer of this is the deepest layer where you still have use resources available as service from solution providers like AWS, Google, and such. Or you can even go deeper to a new layer I came up with called the nothing as a service. This is the deepest layer where you have full control of everything, but you also have full complexity. This is You only go this way if you have very specific AI implementations that you have in mind. Next, now, after talking about these few frameworks, my intention is really to transition into the implementation phase, how we take a realistic look at uncovering the real operation challenges. And again, from last AI Realized Summit, I think this diagram was maybe the most popular from my presentation last year. And it helps us understand how you are integrating AI on top of your existing services, and how you're making these kind of building blocks that are so important. The central point here that will be taking a little bit more time explaining in my next slides is this kind of generative AI service, or the LLM proxy. Before you get to connect with any of the AI intelligence, there is a layer of a gateway that you need to manage and control to achieve a lot of features that are needed to be successful at building AI. And we'll see this in the next slide. This slide here, and I hope this will be the most popular from this year's presentation I have. This is where, over time, as we were building AI into enterprise, we learned that it's so important that you build a centralized component to be able to manage the chaos that comes with building AI in enterprise. It's crucial that this control layer sits between your enterprise application and the diverse intelligence sources you have, the models, the data, the databases, and all of that. And to successfully manage that AI iceberg and tackle one of the challenges it comes with, it's very important to embrace some sort of flexibility into building your AI options by having maybe multiple deployment options from the different options we have seen earlier. Maybe you can go with self-hosted AI, but also use third-party AI whenever needed, because you have very specific features and use cases that are fine with that. So I will be covering some of this, what we call the LLM proxy, or known as the AI gateway. I think there are a few aspects or submodules here that are so important. AI orchestration is where you manage your prompts, your model selection, and you do pre-processing to make sure your everything is ready for AI. The next thing is where you do workload management. This is very classic scheduling, queuing, and batching. It's needed to make sure you do AI whenever you need, and you manage either low priority AI later at points where your GPUs are not heavily used. AI observability is key, and we'll talk about this when I get to the solution level. So this will you have all the monitoring, the logging, the tracing, and there will be a specific focus on what makes this different when it comes to AI, like tracking your token usage, your GPU usage, your cache, KV cache usage. All these things will become more and more interesting later. And obviously you have your AI governance control. This is where we focus more on talking about the guardrails, the safeguards, and everything else. And then before you go into having your request go into your models, you have a networking layer where you manage routing, retrying, load balancing, all of that. Notice that outside of this LLM proxy, to get to talk to the models you have, there is a concept that is very important that will set you up more for success when it comes to solving your problems and complexities. It's more that the understanding that we cannot rely on traditional CPU memory requests per second as metrics to decide for auto scaling and load balancing. And you need to be more LLM based data points and metrics to decide for these. And we'll go through some of this later in the next slides. The next topic is obviously security. You cannot achieve enterprise AI success if you don't take AI security by design. And it's very important here in this diagram. I really want to highlight the cloud systems, the classical security concepts that we all know and have, and think about how you integrate AI security within. And it's very important that you understand that your guardrails and safeguards, the way we do an application level defense against things like hallucination, jailbreaks, prompt injection is so important to achieve your AI success. Another thing is evaluation. This area is always underrepresented sometimes, but you need to be able to evaluate your structure that you built for your AI. And last but not least, as a whole system, you need to always think about AI security as by design. It's something you don't do at the end, you do as you are building your AI infrastructure. Now, going into the solutioning, it's very important to understand that based on my experiences and the projects we went through, I ended up with something I call the AI 3 O's: focus on orchestration, observability, and optimization. The first one, in my opinion, is definitely orchestration. We have arrived at the core technical solution for AI is by achieving this kind of fine-grained orchestration layers. This is the brain of to make AI work, especially in this agentic AI era we're going into. It's very important to be able to connect your current system to the AI system in a very well orchestrated way. So going back into that kind of prompt management, pre-processing of your data, ensuring that your RAG is connected and optimized, and you have your access controls in place, have your guardrails systems running and checking, and ensure that you have the safety categories, the all the validation for the outputs and all of that in place. This is very important. So I think at essence, AI orchestration is the complete operational structure required to manage all complexity for that is beneath the surface that you don't see. So making sure that you have the right tools to achieve optimal AI inference. Now, after talking about observability, like as we go to the next thing, sorry, after we talked about orchestration, looking into observability is so important. AI brings a new set of metrics that you need to track. There are different. I would consider it even a new discipline, like how you track and how you do observability in generative AI. So performance metrics here are very important. Understand latency and throughput, but also these new metrics of time to the first token, these kind of perceived latency, the time per token, how fast your AI can generate these tokens is so important. Understand your KV cache usage, the queue size, the batching size. All of these metrics are so important to understand for the technical teams who are building AI compared to the classical systems, CPU, memory, and requests. Quality metrics is this is where you check the correctness, the accuracy, the evaluate the context, make sure the output is always on check, and make sure your guardrails are running and protecting you from the undesired outputs. And very important last aspects is all these cost metrics. CTOs, technical leaders should think at some point as CFOs. They need to look at every aspect of their implementation to know the cost that it's generating and try to optimize for that. I'm going to take a little bit of a dive into optimization now. After we covered orchestration, observability, it's very important that now that you have the data, you have the metrics, you go and optimize for every aspect of these things. And to achieve that AI nexus, you need to find that right balance between cost, quality, throughput, and latency. Here I covered different pillars, I would say, to the optimizations area. And we will take a little bit more dive into the technical ones because I think it's very important. So, in terms of the technical, this is what, based on my experience, I've been seeing very frequently while building AI for BetterWorks. I think the most important aspects are optimizing for latency and throughput. You need to be able to serve AI as fast as possible, but also serve as many users as possible. All these will lead to optimizing for cost. You need to also ensure that your systems are reliable and scalable. Things that you don't see at the beginning when you go through your MVP and demos might end up killing your projects if your system cannot scale and cannot be reliable. Cold starts is one of these issues when you're trying to do dynamic scaling and you serve more users. The time between your current infrastructure to the next more scalable infrastructure could be so long that no user will be waiting for your AI to scale to that level. AI infrastructure is getting more and more complex, so you need to be able to manage that. And then debug and reproducibility has been a challenge over time, something that we didn't have experience to work on. Before we wrap up, I really wanted to take a real use case from BetterWorks experience, optimizing for AI. And this example here, I took 4 features we had, and I took 2 things we did. One is just to do upscale using a different higher level GPU. And this had a huge impact on our performance, getting to twice faster AI. And the second thing is using model optimization like an NVIDIA TensorRT LLM. This also got our latency and even throughput to get better over time. So it's very important to acknowledge these things that might be end up at the same cost. Like upgrading your GPU doesn't mean necessarily going more expensive. It will, but that will let you manage run your GPUs for less number of hours, and that will reduce your cost. So there's a again going back to the pyramid, finding that AI nexus where you improve some metrics while you optimize for the other ones. Finally, I do believe that, again, we are in a position today that we need to look into these approaches incrementally, really try to not over complexify the solutions, stay informed and not getting overwhelmed with the AI pace of innovation, maintain control, look at cost and resources very seriously, look at privacy and security as every system you ever build in enterprise, and then always evolve your continuous evaluation. Make sure you always evaluate your solutions and go back in loop to improve what comes next for your enterprise AI. That's it for me. I really appreciate the opportunity to speak to all of you, and I hope you find this very helpful and insightful.
Thank you, Maher. I think anyone who is in the process of building their infrastructure or even evaluating it and reviewing it would find this framework very valuable. And we'll need to do a Substack article on it for the AI Realize Now newsletter.
Sure. It would be
All right,
my pleasure.
great.
Yeah.
Thanks so much. And do connect with him on LinkedIn. He posts great content. So if you're a practitioner, especially if you're leading engineering or product, you'll find his posts extremely valuable.